Hi, today you guys will be learning about mitosis and the different stages in it, including prophase, metaphase, anaphase, and
How do
telophase.
cells reproduce? And that's what we're going to talk about today. Talk about how mitosis reproduces. Alright, so the next thing that we're going to get into right now is DNA. We need to know how DNA plays its role in mitosis. You need to know that the two main things that you want to remember about DNA is chromatin and chromosome. Those are the things that are gonna make up your identical sister chromatids. I'll explain that in a bit. But for now, just know that your DNA is located in the nucleus, and that's what controls all your daily cell activities. The two main pieces that we were talking about, the chromatin and the chromosome, just remember that the chromosome is a long thread-like DNA. It's in a non-dividing cell. The one that is in a dividing cell is a double-coiled short DNA. That's your chromosome right there. So how those play roles in the chromosome structure, here I did a little diagram to kind of break it down for us. Here we have an unduplicated chromatin. See how I talked about chromatin being unduplicated? Because it's only one right here. You can see the single sister. When you have a duplicated, two sister chromatids come together. Well, I call them sisters because they have their little bows on already, so that might help you remember. Once these two chromatids attach, they're going to create this identical sister chromosome. This right here, these arrows are pointing at the centromere right here. So that's what's going to help you guys remember that and how it plays its role in mitosis. These two sister cells are going to eventually separate, and they're each going to go into a brand new cell, and that's where we get two brand new cells from a parent cell. And you're going to see how it duplicates itself like we said it would, because the DNA is the same. It's going to duplicate itself, and over here it's going to end up coiling up into one chromosome. So why does DNA need to change from chromatin to chromosome? Just for the fact that it's more efficient for the division of mitosis. So when mitosis divides duplicated DNA into two sets of chromosomes, you know that the DNA is going to coil tightly into those chromatids. The chromatid is going to connect at a centromere. The protein complex around a centromere, that's what is called a connectochore. Hopefully I pronounced that right. It's a little tricky word. And the connectochore is a protein band that is going to bind this sister chromatid right here. It's going to wrap around here in the middle. So that's when mitosis is about to begin. That's when you know mitosis is going to take place. The chromatin packs even more tightly, and that's giving a rise to a visible chromosome. Alright, so overall, the cell cycle, might seem like it's a lot to take in, but it's really not. It's just a series of events that this cell's going to go through while they go out and divide throughout time. It prepares for division, it divides and forms two new daughter cells. Oops, sorry. And each of them begins the cycle again. So here's representing our time, and you'll know that the cell is going to be an interface for most of its lifespan. And from there, you're going to hit, here we go, the PMAT. It's going to hit prophase, metaphase, anaphase, and telophase. And last but not least, the cell division, which is cytokinesis. We'll talk about that later. But it's pretty basic stuff that happens throughout mitosis. A little more here, it's going to be representing the checkpoint right here, apoptosis. This is when the cell's asking, has survivin accumulated? If so, is mitosis ensues? First, we'll have our PMAT right here, prophase, prometaphase, metaphase, anaphase, and telophase. We have another checkpoint right here, which is the spindle assembly checkpoint. And right here, the cell's asking itself, is the spindle built? Do chromosomes attach to the spindle? Are the chromosomes aligned to the equator? So it's just stuff checking itself to make sure that we don't have any bad cell division, because that could cause a problem later on. And here we have a restriction checkpoint, and here's the G1 cell growth phase, and all these right here, the G1, and don't forget this G0 right here, and the G2 phase with the S phase, that's the DNA damage checkpoint. That's where it's asking itself, is this DNA division damaged? Is it going to harm the human host? So it shows you right here where it stops. It shows you right here where it slows down. Again, where it stops. Here in the S phase, it's genetic material. It replicates.
Now that we went over all the basic stuff we need to know to understand mitosis, we could get into the good phases of mitosis. First one we're going to talk about is interphase, the period of growth and development. It's where copying occurs. It's the longest cycle that the cell stays in. It carries out all the activities, replicates all the other organelles. Alright, I decided to get a little creative and show you guys here the different phases of mitosis through sugar cookies and some colored frosting. So the first thing I want to talk about before I get into this, you're looking at the prophase, is the early prophase and what happens during that time. Just to show you real quick what we talked about, the spindle fibers would be represented by these white lines right here. We're going to have some asteroids that are not represented on the cookies, but this right here, these little green highlighted areas are your centrioles. And what we have over here, this is what your chromosomes are. These are your two sisters right here. So what happens during the early prophase, that's when the chromosomes coil up tightly so they become visible. I was able to represent late prophase right here. Here you're going to see the chromosomes and the two sisters chromatids. So what happens here, it's a result of DNA replication during the S phase. Remember that in the cell cycle I showed you? That's the S phase. It's two copies of each chromosome. More about the late prophase, you have to know that each copy is what's called a chromatid. It's connected to its duplicate at the single point of the centromere. Remember the centromeres? They're these right here. The connectocores, that's what's going to be those are the protein bound area of the centromere. They attach the spindle fibers, forming chromosomal microtubules. And that would be represented right there. The best way you can remember this phase right here, just know that when all these chromosomes are lined up in the middle like this, they're in the middle. That's how you can remember metaphase. M, middle, M, metaphase. What happens in this stage right here, all the chromosomes are lining up. As you can see, the spindle fibers are connecting the chromosomes right here. A little bit more, this is when metaphase ends. This is when all the chromatids are aligned in the plane of the metaphase plate. The metaphase plate is this right here. It kind of looks like a plate too if you think about it. So the central zone, that's where the chromatids move to a narrow central zone. That's going to be this right here, the center of that. Here's a really crappy cookie representing anaphase, apart. Apart, anaphase, apart, that's the best way to remember it. Here you have your chromosomes. They're now dividing. They're going their separate ways. The copies are dividing. The spindle fibers are the ones that are pulling the chromosomes to opposite poles, and eventually that's going to break off into a completely new cell. So this is how you know that two daughter cells of chromosomes are now pulling towards the opposite ends of the cell. Along right here, the last but not least, you have your telophase, represented by these two weird looking things on the cookie. This is where your chromosomes are finally uncoiling. The nuclear envelopes, they're forming again. You could see that happening right here. They're forming again. Two nuclei are forming right there. These little things, that's the nuclei forming. These spindle fibers, they're disappearing. You can't see those spindle fibers anymore. This is a very important stage. This is where each new cell prepares to return to interphase. The nuclear membrane reforms. The nuclei enlarges. And it gradually. So here you guys are looking at the cell cycle. It's a cookie representation of it. This right here, it's going to be your little S phase. When you come over here, it's going to be your G2 protein synthesis. All this over here, pink stuff, yep, that's mitosis right there. And over here you got your G1. So if this could kind of help you, give you another representation of what portions take up more hours in terms of how the cells are dividing, this is pretty good. This is your interphase stage right here, happening, all that. Thanks for watching my video, guys. Now it's time to eat up all these cookies.